Okay, so now we're in the next section where we're going to be talking about debugging logic errors. This is a very important section as well because as developers, we need to know what the results are before we write the code. Again, we saw an example where we talked about the your pay week. In our minds, we know there's 7 days in the week, but we may only work 5 days a week. And so when we write the program or the function to calculate the time that we actually worked versus how many days in a week, can give us a logic error because, like I said, if we wrote the algorithm to be 7 days, it's not going to give us an accurate result. And so therefore it's a logic error because we're not looking for it to give us a 7 day breakdown, but we want a 5 day breakdown. And so the console is not going to give you an error because the syntax is correct and also the runtime is correct. It's the logic that's not correct. And that's where it becomes a challenge to debug because sometimes you're racking your brain. Why isn't this giving me the result I'm looking for? It's because the logic that you wrote was incorrect and the computer is not going to fix that. So we're going to go into that part of the section of debugging right now. But first, before we go forward, let's recap. Again, we're getting more information and I'm giving you more information every time you watch a new video. So what's happening is we're overloading your brain with a lot of information. I just want to let you know that it's easier to plant a seed than it is to plant a tree. And depending on what level the tree is, the harder it is to plant it. So right now, we have to continue to keep reviewing because as you go further on into the curriculum, we're going to keep giving you even more information and more complex information. So let's take the time to really understand these small little nuances and rules and principles now and concepts now. So later on, you will be able to recall them a lot easier. So with that being said, we just reviewed and went over a couple of things. We first understand about the syntax error and we learned about the reference error, which is the runtime error. So get familiar with those errors. What is a syntax error? What is a reference error? When do they occur? What is the precedence of those errors? Which one is going to cause an issue first? So it's important that you take the time to truly understand all of these small details now. So later on, you'll be able to recall them a lot sooner. Okay? So again, if you're coming to this channel from wherever and you're just seeing this for the first time, this curriculum is free. The link is in the description and you can follow along. You can go back and watch all the other chapters where we are teaching you programming. And so it's a great resource. So now let's get into the curriculum. Debugging logic errors. We can debug runtime and syntax errors using the error message produced. Logic errors, however, do not generally produce error messages. This sometimes makes them tougher to debug. While we can't provide a step-by-step approach that applies to every possible logic error, we can give you some solid strategies. Two such strategies using debugger tools and writing tests will be covered in future lessons. In this section, we start with a basic and effective way to debug logic errors. Again, this is one of those seeds. Later on, we're going to show you, like we said, we're going to go over how to debug and how to write tests. But we're planting the seed now. Printing values. When your code runs but doesn't produce the expected results, it is important to check the values of the variables being used. Let's look at a program that has a logical bug. Here we have an input, and I'll go over this. What are we doing here? We're using the const keyword, so that's letting me know that input it's not mutable, it's sealed. This is what it is. We don't want it to change. Whatever this value is, we don't want it to change when we use a const. And then now we're creating a degrees C. So that's descriptive, and we're passing in that object, which input is now an object. That variable is an object, and we're going to pass it the question method. How do I know it's a method? Because it has the parentheses behind it, and we have a dot access modifier, and we'll explain more about that later on. And we're passing in a string to prompt the user, because this is what this does. It's prompting the user. And this code that is written for you is abstraction, because you didn't write this method. And inside that method, it is giving us some logic, some information on how to collect some data. And then once the user gives us their input, it's now going to be stored in this particular variable, which is now an object. Then we create another variable by declaring and initializing it with that same input that the user has given us. And now we're going to add 273.15. And then now when we console.log degrees and degrees K, it's going to print. Because remember, console.log means to print. There's more to console that has it has more than one method. We're just teaching you log. There's more methods that you can use on console, and I may introduce some of those as we go further. But here, this program asks the user for a temperature in degrees Celsius and attempts to convert it to degrees Kelvin. Degrees Kelvin differs from degrees Celsius by 273.15. So if we were to enter 100 in Celsius, we should see a converted value of 373.15 in Kelvin. However, running the program as is and enter 100 gives the message. Temperature is degrees Kelvin 100. And look what it did. It concatenated the value. Now, go back and think about this for a second and understand why that is. There's a rule here that you need to understand. So get your head wrapped around it now. So later on, when we're using, giving you your assignments, or if you're going through your studios and your exercises, remember what the rule is. Now, this is clearly incorrect, but the program does not generate an error. See, it didn't give us an error. So it is not immediately clear what the issue is. To figure it out, we'll use console.log to see what the values of the key variables are when the program runs. Here's a great example of how to use console.log to get information back, right? So let's first make sure that the degrees Celsius variable looks like it should by adding a console.log statement just after we created this variable. So here, when you run this in your code, you're going to have to use VS Code for this. Now, this is where we're going to get comfortable with VS Code. So you're going to run this code right here, and you're going to pass it in this console.log, and it's going to give you back, print something to the console, which is the degree C. This is why you want to know what's being stored. So when you input the question to the user, you want to know what information was being stored inside of this variable. Now, once you do that, it's running this with the input of 100 gives the output. Now, this doesn't look like anything. You can't really tell, and you can't trust that the colors of this, but what it's saying is this is a string because it's white, but don't trust that. Understand what it's doing, because this is 100, and we know that inputs automatically turn everything into a string by default. The second line is the value of degree C, which appears to be correct, but the final answer is still incorrect. So we need to keep digging for more information. Looking at the line in which we set degrees K, we see that we use degree C as a numeric value in our calculations. Let's see what the data type of degree C is. In the end, we want it to be a number. So now you're seeing the importance of using this operator, type of operator, because you don't know what it is. You don't know what degree C is, because degree C is a variable that is storing information that we're getting from the user. So now using type of is in its best interest for you now, because you're debugging and you can't understand why your logic is wrong. Technically, you didn't write the code wrong, but the result isn't right because you didn't understand the rule. You're missing the rule. And the rule is what? Everything that you enter into a field is going to by default be a string. This is where the practice is going to come in at, for you to remember it. But it's better for you to recall it now than you wait 3 or 4 more weeks from now when we get deeper into the chapters and you don't remember, why am I getting this error? Why this is not working? And you get frustrated. But if we take some time to understand it now, later on, it's going to make sense to you when you see this issue, because it's easy to forget that you need to do something. And so if we want the number to be a number, we're going to have to do some converting. So this is a good lesson to understand that now. So here, like it says, running this with the input of 100 gives the output. So we see it tells us that it's a string. That's it. The variable degree C has the value 100, but it is a string rather than a number. So when we set degrees K with the formula degree C plus 273.15, now remember, this operator right now has 2 purposes depending on the value. We are actually performing string concatenation instead of addition. This is why you want to understand what it is doing as opposed to just memorizing the syntax. We can fix our program by converting the user's input to the number data type. Here's an example how to do this. Remember this, understand this, because you're going to use it later. So again, when we get the input from the user, what did we do? We went on ahead and we stored it into, we converted that degree C to a number, and we put it inside of this particular variable now. So now degree C is holding the input and it has converted it to a number. Now, I want you to play around with this, because there's another way you can do this. There's a shorter way you can do it. You can play around with the code. What will happen if you were to put this whole thing, input question, inside the number function up here instead of having to reassign it? Because remember, we're going top to bottom, line by line. So get familiar with refactoring your code. So here we are. Running this with an input of 100 gives the output. Now it gives us the correct result we're looking for. Note that after debugging, we removed all of the consoles.log. Remember, you have to do that. It's easy to keep those console.logs in your code when you don't need them. So we're only using console.log for testing purpose and debugging purposes. You don't want it to be in your final code. Be sure to do the same when using this debugging technique. Now, understand something also. Every once in a while, depending on the use case, you may leave a console.log in for whatever reason, but there's use cases for that. But right now, we want you to remove them once you're done with the console.log. So again, understand you need to know what the result is before you write the code. So if you know that the result is supposed to be, in this case, converting Celsius to Kelvin, you know what that result's supposed to be. So down the road, you're going to have a lot of tests that's going to, you have to write the code correctly to cover different tests. That's when we're going to teach you testing later on. But right now, we're planting the seed. Now, that's the end of this video. Remember, the more you do, the more you improve. See you in the next section.